And that can just keep going. I can just keep either adding or subtracting 360. Okay. The other thing we want to talk about is something that ends up being really important when we're understanding conceptually what's going on with the unit circle, is the idea of a reference angle. Okay, a reference angle is basically the angle that your terminal side makes with the x-axis, the smallest angle that does that. So for this one, the reference angle is going to be 40 degrees. I'm going to see if I can have another color here that I can use for this. Okay, so the reference angle would be literally just the angle to get between the x-axis and the terminal side, the closest possible angle we can make with the x-axis. All right, so if this out here is 180 degrees all the way to there, we've only gone 140 degrees, then that leaves me with a reference angle of 40. That's not showing up very well, but hopefully you get the idea. Okay, it's reference angle of 40 degrees. So we probably should practice that concept a little bit. So let me move that, and we'll bring a different sheet in here. Okay, so let's say I had an angle of 290 degrees. Okay, the first thing I want you to do is to think about where would that angle be, which quadrant. It'd be in the fourth quadrant. Again, this is 0, 90, 180, 270, and a little bit more would be 290 degrees. Now that's measured from here all the way around to there, 290 degrees. Okay, so now we found our angle. Can you develop another angle that has the same terminal side, but it's literally a different angle? Should be able to develop multiples. Let's do the easiest ones. The first one would be an angle of negative 70 degrees, right? Because all the way around would be 360. I only went to 290, so there's a 70-degree difference here. Another angle could be adding 360 to 290, so going another full rotation. And that would be 650 degrees. Or we could subtract another 360 from negative 70 and get negative 410 degrees, or 430 degrees, sorry. So those are some options. All right, then lastly, what is the reference angle here? Well, the reference angle, remember, is not the angle between the terminal side and the closest line. It's only the angle between the x-axis and this terminal side. So that angle measure right there, think of it as a positive. So in this case, we're not thinking about negatives or positives. It's always going to be a positive. That's a 70-degree reference angle. All right. Why is this important? Well, this is important because now this 70-degree reference angle, if I take another angle and I put it up here, that's also 70 degrees away from the x-axis, it's going to have some similarities in its coordinates compared to this point. All right, and so let's talk about that. So if I pull out my calculator, first thing I want to do is I want to make sure that my mode is set to degrees, because if it's on radians, then this is not going to give me information in degrees. And right now, we're working in degrees. So make sure it's on degrees and then quit, and then you should be able to do this information. Now we just talked about how the x-coordinate is going to be cosine of my angle, which is 70 degrees in this case, and my y-coordinate is going to be sine of that angle. So if I do cosine of 70, that's going to give me 0.342. We'll go to the nearest thousandth. If I do sine of 70, that's going to be 0.940, really, if I were to round to the nearest thousandth. So 0.940 and 0.342. Those are the coordinates of this point. Okay, so then this angle down here at 290 degrees, the one we started with, this point should actually have some similarities to this point's coordinates, because it's the same angle this direction. It's just, instead of being positive, it's negative. So what would you think the x-coordinate of this point is? All right, the x-coordinate of this point is going to be 0.342, the exact same x-coordinate as this one. Why is that? Well, if I've rotated around a circle, again, my drawing's not great, but if this is a purely perfect circle, then the same angle this way and the same angle this way should produce a similar x-coordinate, or exactly the same x-coordinate, I should say. Now, what about the y-coordinate? Is there any difference between the y-coordinates here? Well, yes, this one's positive, this one's going to be negative, but they should have the same value. So this one's going to be a negative 0.940 x-coordinate, or sorry, y-coordinate. Okay, so hopefully that's starting to connect. So if I know an angle, and I know that I have another angle that has the same reference angle as it, then the coordinates should have some similarities. Okay, so just to recap here, when we're looking at 2 points that have the same exact reference angle, 70 degrees, they're going to have some very similar components. Those components basically are their x-coordinates, should be basically the same number, and their y-coordinates basically the same number, just potentially an opposite sign. That means that even when I go over here, so if I find the point over here that has a 70-degree reference angle, it's going to have some coordinates that are very much the same. Instead of being this direction, 0.342, it's going to actually be this direction, 0.342. So it'd be negative 0.342. But it should have the same exact y value as this point, so 0.940. All right, so hopefully that gives you kind of a clue as to what's going on there with the unit circle. So then the next thing we need to do is look at just, how does this idea of sine and cosine come into play? Oh, actually, sorry, before we do that, I want to make sure to show you that this angle here that we said was 290 degrees, if I put the cosine and sine of 290 into my calculator, I should be getting the same coordinates. So here's my x-coordinate, 0.342, and then if I do sine of 290, then I should be getting negative 0.940 like I had over here. All right, so I want to make sure that, to show you that you could definitely check that in the calculator if you needed to. Okay, so moving on, I want to talk a little bit about sine and cosine. If you remember, we talked about how sine is opposite over hypotenuse. This goes back to SOHCAHTOA. So if sine is opposite over hypotenuse, that means it doesn't matter what triangle we're dealing with, sine is a ratio of sides. Okay, it's the ratio between the opposite side from the angle and the hypotenuse. So this triangle, I could make this a huge triangle. Okay, I can make it, I know I'm going into my other space here, but I can make this huge triangle that's similar. If you remember your geometry, this is a similar triangle as long as I make this line over here a perpendicular line to this line and make this a right triangle. We have the same angle here. This is a similar triangle. What's awesome about sine, cosine, and tangent is that since they're representing ratios, they're just telling us that if I take my opposite side over my hypotenuse for any given triangle, if it's the same angle, any given right triangle, sorry, if it's the same angle here, that ratio is going to be the same no matter what. And what's great about that is that means that I don't have to just focus my energies in the unit circle. I can actually extend this information then into circles that have a different radius. So we're going to use this as an example for that. So this particular angle that we're dealing with right now is 52 degrees, and the circle is not a unit circle. The circle, in this case, has a radius of 4 instead of a radius of 1. So, how would we go about finding then the coordinates of this point? Well, what we would have to do is take what used to be the unit circle, so a radius of 1 would be down here, and we're just extending that out. This is 4 times longer than it was. The great thing about this is that because our sine and cosine values of our angles are based on a unit circle that has a radius of 1 here, then if I just take this height, whatever that would be when I find my angle, or sine of my angle, and I multiply it by 4, now it's going to be the height that it would be 4 times bigger. So bottom line here, in order to find the coordinates of a point that's on a circle with a radius that's not 1, it's something else, then you just take x to be r times whatever cosine of your angle is, and y is r times sine of whatever your angle is. All right, and that's pretty awesome. So then all that means is we need to get out our calculator and do that instead. So this one is an angle of 52 degrees. It has a radius of 4. So I'm going to do 4 times, sorry, you probably can't see that very well. We'll do 4 times cosine of 52. And that's giving me 2.463 to the nearest thousandth. And I do 4 times sine of 52. And that's giving me 3.152. That's really all it takes. So really at this point, you have all the skills and knowledge you need, well, all the knowledge you need in order to produce your skills next class. And then once we get those skills down pat, I think you're going to feel really confident in this.